Well, hello and welcome back to the Andrew Eborn Show. And I'm delighted to be joined yet again by Pratik Desai. How are you doing?
Brilliant. You got my name right.
I love it. I've only been teasing you, because last time it's all the people have been writing in saying, what's he saying about our poor pets? And we were saying...
Absolutely. Well said. That's interesting. Absolutely.
It's all good stuff. But we are, and this is what we've been doing in this series. We've been looking at the problems, because it's by understanding the problems in the first place that you recognize that something should be done about it.
Absolutely. That is absolutely the point. Yeah.
And so today's problem, what are we looking at?
We're looking at ammonia today. Ammonia is basically one of the most important commodities known to man. We have been blessed with ammonia thanks to the Haber-Bosch process. In fact, the population, whatever it is today, the doubling, all of the requirements and the ability of the Earth to sustain the planet has all been down to ammonia. But, and there's a big but there, we spend 2% of the global energy on producing ammonia. It accounts for about 2 to 2.3% of the global CO2 emissions, just by itself on the production-wise. It's used in all fertilizers, it's used in dyes, it's used in paints, it's used in clothes, foodstuffs, everywhere. And because of that, it ends up in our waste streams. Since it ends up in the waste streams, the problem with ammonia is that whilst it's produced by all organisms as well as a byproduct, we have this issue that ammoniacal nitrogen, which is the liquid form of ammonia, tends to be highly pernicious to the environment, especially to the flora and fauna, so plants and animals. They do not thrive well in ammonia, and is as low as 10 milligrams per liter, lower for many organisms, is harmful for them. So what happens then is you really want to get to the point where you have ammonia treatment methods. However, people currently treating ammonia use up almost half to 1% of the total energy of the world to destroy this ammonia that's been created, because it's so harmful. And that, to me, does not make sense.
No, it makes no sense at all. I'm very worrying statistics. You're very good with all these statistics and so on and so forth. But the bottom line is it's a problem, isn't it? And I think people need to recognize that problem and the difficulties that's involved. So what's the solution?
The solution absolutely has been that, firstly, remediating ammonia should not be a cost incurred. It should be, hopefully, as the basic feature of my all of my technologies and inventions has been, is to provide a sustainable but also a circular economy approach. And it's a cascading one, because if there are multiple steps, each step has a value added to the system. So the approach for the ammonia is what we call as the Desai-Zimmermann waste factory. And it was effectively a solution provided for that, so that we could extract the ammonia from a waste stream. And it's using something called a stripping unit, okay? Not the sensual kind, it's a chemical engineering operation. And we're able to extract this ammonia and recover it rather than destroy it at a rate which is faster than any process known at the moment. So we do it 15,000 times faster than conventional processes.
Good heaven. How on earth do you test that then? When you say, as I say, a lot of the facts and figures that we get, we peer test them, we subject them to scrutiny. How do you know it's 15 times as fast?
Oh, it's 15,000 times as fast.
15,000 times. How do you know that?
We know that because we've tested it with the end users. We've worked with some of the large waste management companies. We've also had third-party testing done on them. The results, which are the same people who've done it for governmental testing. And we've got these results which are, and we've won a few awards on them. Effectively, we are absolutely sure we are recovering the ammonia. And not only that, we are not taking out the ammonia, we're recovering it. We're partnering with companies which are focusing on producing fertilizers from this ammonia. We have solutions for, okay, this is leachate or landfill leachate is an example, or waste stream. And this has a host of other chemicals in it, heavy metal ions. So you throw a battery out, it goes into heavy metal. Some of the heavy metal leaches it out. You have cans, something, because those things that don't end up in recycling sometimes end up in the landfill. So all of these things contaminate the waste stream. So you've got ammonia and you've got thousands of other chemicals. What we do is, firstly, the ammonia is recovered with this process. Then the rest of the stuff, which is there, we used engineered organisms and these are not genetically modified, they're just standard organisms which have been adapted to work there, to extract as many nutrients as possible. So think about phosphorus, another big issue in the waste streams at the moment. Heavy metal ions, another thing. We take it all out, and then we combine it and make strong value-added fertilizer from there as well. So we've got a fairly strong and robust policy of cleaning up the water, which was originally a big cost. That cost has been removed almost entirely. Well, 90% of the cost has been removed. Now we've generated an upcycled value-added product. So this is what the major solution is out there. And it cost-wise, it's very, very strong as a case. And we are pushing into the pilot, larger than pilot scale for this process now. We have individually demonstrated each of these processes. Now we're putting them together to give that total cycle a chance to win.
And 15,000 times as fast has got to be good. You talked about awards. Talk to me about some of those.
Well, so chemical engineering has a professional body called the IChemE. We won the IChemE's, so I was a finalist for the top young researcher. I've also been the finalist for the top prize in energy. We have the Anaerobic Digestion and Biogas Association Awards, which is one of the top.
That's bodies. A snappy title, isn't it?
Oh, absolutely. But that's the top AD body globally, which has a host of other people. And we won 2 awards from them. One of them was highly commended for a research project that we started with our partner, Viridor Waste Management Limited, which is the 3rd largest waste management company in the UK. Then we won the next one again with Viridor for another collaboration we had, where we won the award for the best R&D, industrial R&D innovation. So these are just awards that we have been invited for and we've thought of going for, but we have been invited for other awards as well, as from the head of committee or head of nomination committee saying, oh, we would really like you to apply for this, for the award. And generally speaking, we didn't have the bandwidth.
Yeah, but what's interesting as well, though, isn't it? Is it's basically this is the peer approval. This is what I'm always looking for when we're talking about this sort of solutions. Understanding the problem, having a look at some potential solutions, but also how does the industry, how do the peers respond to that? And awards is a great sort of barometer test, isn't it?
Oh, absolutely. And this is one of the things. I'm one of the few non-waste industry professionals to be in the 35 under 35 for the Waste Industry Limited as well. And the other part was also the fact that peer review, but also importantly, I believe this because I come from a scientific background. My partners in the company come from a scientific background. So we are very focused on getting pure core science right and core engineering right. But then I also come from a commercial background, which then focuses on actually, is the solution the best thing possible for the industrial partner? Are they stakeholders in it? So that's why I always call ourselves a collaborator, not a supplier. And we have developed these partnerships, strong partnerships, because of the fact that we have a solution that's tailor-made for that system and that sector, which is giving us a very strong selling point.
Yeah, and I love the idea of collaboration. Pratik, thank you so much for joining me. We'll get you back to talk about more solutions. But for now, if you want to get any more information, pop along to envisionation.org. We're going to have more of those videos there. Pratik, thank you for joining me.
Thank you, Andrew.